and welcome, and in this video we're going to be taking another look at synthetic division. Now if you haven't watched my original video on polynomial division, make sure you go back and watch that. I do introduce synthetic division in there, but I first cover long division, and I do feel it's important to first see long division before synthetic, because you can only use synthetic in very specific instances. One of those instances would be something like this. So say we had this polynomial problem. We wanted to divide 3x cubed plus 11x squared minus 18x plus 10, and we wanted to divide that by x plus 5. Now remember, long division can be used in any polynomial division problem, but we can use synthetic here, and that's because we are dividing by a linear binomial with a leading coefficient of 1. Now remember the setup for synthetic division. We put a number in the box is basically always going to be the opposite of this number here, as long as the leading coefficient is 1. And remember, you can only use this when you're dividing by a linear binomial with a leading coefficient of 1. So I'm going to put -5 in this little box by itself, and then we go ahead and we write the coefficients and constant of this polynomial. So 3, 11, -18, and 10. Okay, and then we go ahead and we draw a line. Now remember that each of these places represent a specific term. So this represents the cubic place, this represents the quadratic place, this represents the linear place, and this represents the constant. Okay, now remember, if there is a term missing, we need to hold this place with a 0. In this problem, we have all the terms, cubic, quadratic, linear, constant, so we don't need to worry about that. Now we always bring down the first number, remember, and now we multiply this number below the line by the number in the box. In this problem, that's going to get us -15, and we put that in the next place, and then we add. So we're going to add 11 to -15, that's going to get us -4, so -4 comes below the line, and now we're going to go ahead and multiply by the number in the box, so -4 times -5 is +20, so we put that in the next spot. We add -18 plus 20 is 2. And now we multiply by the number in the box. 2 times -5 is -10. And this adds to 0. Now remember, this isn't always going to happen. We're not always going to have a remainder of 0. But what that means is that what we divided by is a factor. X plus 5 is actually a factor of this polynomial right here. That only happens if the remainder is 0. And that's really important because we are going to be using division to actually solve polynomials a little bit later. Now also remember that when we divide by a linear, all these terms are going to go down exactly 1 degree. So this isn't our final answer. These are just the coefficients and constant and possibly remainder of our final answer. So what this means is that this used to be 3x cubed, but we broke it down, and now this is broken down to 3x squared. This used to be 11x squared, but we broke it down to -4x. This used to be -18x, we broke it down to a +2. And then this used to be the constant, but we broke it down to a remainder of 0. Notice how we used to have x to the third, x to the second, x and the constant. We broke that down. So everything goes down by 1 degree. Basically, the exponent goes down by 1, and this would end up being our final answer. Now, remember, that is synthetic division. If there's any questions, make sure you let me know. Now, I do want to cover just a couple more problems just to be safe, and one of these is going to be a specific instance where we actually are missing a term. So let's go ahead and take a look at that problem now. So here we go, we have x to the 4th plus 2x squared minus 9x minus 7 divided by x minus 2. Now, once again, we're dividing by a linear binomial, so I could go ahead and use synthetic division. You can always use long division, but we also could use synthetic division here. So I would be putting 2 inside the box because the opposite of -2. Remember, another way you can think about this is if you were to set x minus 2 equal to 0 and solve, we would get 2, so 2 goes inside the box, okay? And now we write our coefficients. So we have x to the 4th, which was 1x to the 4th, x cubed. Wait, we don't have an x cubed. This is what I was talking about. If we're missing a term, this went from x to the 4th to x squared. It's missing x cubed. It's missing the cubic term. We need to hold this place with a 0. So we have 1x to the 4th, 0x cubed, 2x squared, -9x, and -7. So there's our coefficients and constants. We draw the line, we bring down the first number, and we start the process. So I now go ahead and I multiply the number underneath the line 1 by the number in the box 2. So that multiplies the 2, and then we add, and that's going to add the 2. Now, just so you know, just like if you get a 0 in here, okay, if we're missing a term, it would be represented by 0 in here. We can also end up with a 0 down here, and that just means we'd be missing that term as well in our final answer. So don't be scared or alarmed if you end up with a 0 anywhere before the remainder. Remember, you get a 0 for the remainder only in the very special instance that you're actually dividing by a factor. And now we continue the process. So we do our number underneath the line 2 times our number in the box 2, and that gets us 4. And we add, so 2 plus 4 is 6. Now we continue. So we have 6 times 2. That's going to get us 12. And then we add negative 9 and 12 are going to get me 3. Then we have 3 and 2 that multiplies to 6. And we add to get negative 1. So notice here that we do have a remainder. That means we did not divide by a factor. That doesn't mean we're wrong. It just means that we didn't divide by a factor. And now we can write our final answer. Remember, we started with an x to the 4th. We started with a quartic, but we divided, so we're breaking it down to a cubic. So this used to be x to the 4th. It's now x to the 3rd. So this is going to be 1x cubed plus 2x squared plus 6x plus 3. And now we have a remainder, so we can write that as plus negative 1 over what we divided by. Remember, the remainder always goes over what we divided by. And just so you know, you could have plus and then a negative 1 in your numerator, or you can just change that plus to a minus sign and have that as a positive 1 in the numerator. Both would be completely acceptable, and that is our final answer, okay? Now, I do want to just try one more just to be safe. If you feel like this is enough, feel free to stop here, but I'm going to go ahead and go over just one more problem. So let's go ahead and take a look at that problem. So here we go. Let's take a look at this problem. Now, right away, I can see that I'm not missing any terms. I have x to the 4th, x cubed, x squared, x constant. So we're not missing any terms. We don't need to hold anything's place with a 0. And I'm also dividing by a linear binomial with a leading coefficient of 1, so I can use synthetic division. So my number in the box for this problem is going to be 1, because if I set x minus 1 equal to 0 and solve, I would get 1. And now we're going to go ahead and write our coefficients. So 3x to the 4th, 5x cubed, negative 10x squared, negative 8x, positive 3. And we start the process. Always bring down that first number there. So I'm bringing down 3, and now I start the process. So I have 3 times 1, that's going to get me 3. And then I add these two together, that's going to get me 8. Now I'm going to go ahead and multiply 8 and 1, that's going to get me 8. And that's going to add to negative 2. From there, I'm going to go ahead and do negative 2 times 1, that gets me negative 2. That's going to add to negative 10. Then I go ahead and I multiply negative 10 and 1 gets me negative 10. And 3 and negative 10 add to negative 7. And there is our final answer. Kind of. It's almost there. We just got to write it out now. So once again, we did get a remainder, so we're not dividing by a factor, but that is okay. So we started with an x to the 4th. We're breaking it down to an x to the 3rd. So we're going to have 3x cubed plus 8x squared minus 2x minus 10. Remember, we do have a remainder here, so we have a remainder of negative 7. So we can write that as plus and then negative 7 over x minus 1, or we can write that as minus 7 over x minus 1. And this would end up being our final answer. Hope this was helpful. If you're still not clear with synthetic division, please feel free to let me know. I do want to help. This is an extremely useful concept that we use a lot with solving polynomial functions, generally when we have to use something called the rational root theorem, which is coming. Now, in the next couple of videos, we're going to be talking about factoring and solving polynomial functions. We'll also talk about graphing polynomial functions and polynomial inequalities. So if you have questions, please feel free to let me know. Otherwise, I look forward to seeing you guys in the next video.